Hello, so today we are going to try to solve this problem called length of longest Fibonacci subsequence. And the problem says we have a sequence, right? X1 to Xn, which is Fibonacci-like if its length is bigger or equal to 3, and xi plus 2 is equal to xi plus 1. So we could also write this as xi is equal to xi minus 1 plus xi minus 2. And given a strictly increasing array of positive integers forming a sequence, we want to find the length of the longest Fibonacci-like subsequence of A. So for example, here, so this sequence here, we have 3, 1, 2, that gives us 3, right? And then 5 from 3 and 2, so we could just, it's subsequence, so we can skip elements, so we have 1, 2, 3, and then 5. And then after that, for 6, if we take 5, we can take 6. 6, 7 don't work, but 8 works. We could try a couple of them, but this is in this example, this is the longest subsequence. So for this one, well, 1, 3, 7, that doesn't work, but 1, 11, and then 12, that's a sequence of length 3, so we can return 3 here. Okay, so let's see how we can solve this. This definitely sounds like a dynamic programming problem, right? The main problem though is that, so for example, if we look at this sequence, one solution could be 11, 3, 11, 14, right? If we didn't have, let's say if we had 2 here, then this will certainly be a solution, 3, 11, 14. So how can we figure this out? So what this would mean here is that the first element is not always the start, right? So that's an observation. The first element is not always the start. And one problem also is that the first 2 don't count. We count them with the third one that is valid. So the thing to think about here is what are the choices at each point, right? So, and what is what is the state? What are our choices? And then we could try to come up either with a recursive solution or a deep solution. Recursive, of course, with memorization as well. To clarify there. So the state here, we definitely have I, right? And then we have we kind of need the last 2 elements in the sequence, right? And the choices each time is, it's a subsequence, so pick or leave an element. So I last 2 element in the sequence. The choices is picking or leaving an element. So we could have a function, we could have a helper function here, let's call it with I, and then maybe the sequence. This would be the subsequence that we have. That we return the length of, right? And so here, if I define a helper function with I and then the sequence, what would be the base case? So the base case would be if n, which n is the length, if I is equal to n, then we are done, right? And then we have the recurrence, which would be a helper of I sequence. Well, we have the choice, right? So when we want to take the one that has the max length, right? So we have two choices. One of them is picking the element, so that would mean helper here with I plus 1, and the sequence is going to contain the element, but we can't do that only in one condition, right? So this would be AI, but this choice is available only if the element at this position is equal to the previous element plus the element before that, right? If that's the case, then we can return, then we can do the choice 1, otherwise we would have to skip, and skipping means just calling with I plus 1 and the same sequence. And here we need to return the length of the sequence if that happens, and we could choose here to initialize choice 1 to 0. And at the end we will need to return the max of choice 1 and choice 2. Let's try this. So so the first thing we need here is to define this as the length of A, and if I is equal to n, just return the length of the sequence, and find some things here. So choice 1 is equal to 0. Do this. Choice 2, just return the max of choice 1 and choice 2. This is A of I. And then we will need, sorry, this is not done yet. We'll need to start the call. So the first call is going to be helper with 0 and an empty list, and then at the end we could just return whatever this screen returns. Yeah, sometimes it's empty. So here the sequence has to be, the length of the sequence has to be at least bigger than 1, right? Because so that it can be at least 2. Interesting that it's still let's try to see here. Let's see what sequence contains. It's empty. Interesting so far. And that's the only one we reached. There is a problem there because Okay, seems like we never added which, this may be because of that. Yeah, we need to launch the first one, so either it's less than or equal to 2, less than 2, which means it has at least 2 elements because we want to try those. Cool. Yep, so that seems better. Now let's comment this and try some other examples from this. Okay. Okay, so the second one has a problem. Okay, let's see. The second one. Maybe you can remove these two. Try to reproduce it with a smaller set, which here it fails. It should have said 0 because we'll see the sequence that we got. It should be 0 if the sequence length is not. So 7, that's not correct. Like, so 2 means the first element. Actually, what we need is less than 2. Okay, and then the sequence here, we should consider it only if this is bigger than 2, else we should return 0 in that. Consider it because it's not a correct sequence here. Cool. Now, if we kind of increase with 12, still works. Let's try this. Okay, cool. Let's try this. Okay, great. Seems like most of them work. Let's try with a couple of other. So we'd have, are guaranteed to have at least 3 elements. Try this sequence. Modify it a little bit. 7, 9, 21, 26, 31, 42, 57, 67. Let's try those. Okay, looks like it works. Submit. Oh, it's probably will tell me I need to cache these results. So an easy way to do that I can do here is just import hello cache none, and then what do we need to import that? The other way that is probably better here to do is to just memorize myself. So instead, let me just do that. So I need to memorize. And here, if actually, let me just choose iterative cache because this one is getting a little bit more complicated. So iterative cache. It's just functool. So import iterative cache. And let's do iterative cache none. Yep, because the parameter list is unhashable, so we can't really do that. We can cache with the two last elements, right? So this would work easier if we have previous and before previous, and both can start out as none, right? And then here we could say if not or not prev, or we have that, and then here, well, prev is going to be, before prev is going to be prev, and prev itself is going to be just the element. Here we will need to just send the same values. And here this would be before prev plus prev. And here we need to send the length of the sequence. Yeah, that won't work. Let me do it with memo like this. So here, if both I and the if the length of the sequence is bigger than 2 and, or actually let me just do this quickly with just I and then just join sequence and call this the key. This needs to be improved, but let's go with it for now. So this would be the key, and then if key is in memo, then we could do memo for key, and just return that, right? Otherwise we will need to define this and then return it. Yeah. Let's go back to sequence here as the parameter. So this actually should work, right? Yeah. The problem is when it's empty, right? I think that's, yeah, that should be fine. What about when it's just one element? Yep, that's the problem. So this is if is bigger than 1, else we could just go with I, right? Just go with I and then sequence 0. It's different now. Would it work with just I? I'm thinking probably it won't. Maybe. Let's just make it start with 0, right? To make sure we don't get issues. Why would, so 0 plus 1, 2. Oh, I see, okay. The problem is not that at all. The problem is that it needs to map str to that. Yep. And with that, we could get away with. Yep, that's the problem. So it needs to be map string to the sequence, and that way we are done. Okay, should submit. So getting taily here. We probably will be better off trying to convert this to a dynamic programming solution. Yep, I didn't actually. So if the key is in memo, we could just return it. Otherwise, we save the choice. Okay, I think we need to turn this into a DP solution. So to do that, well, we need to determine what is our goal, right? And then what is the state? What is the base case? What is the recurrence that we are going to go with? Right? So the goal here is the longest is the length of longest Fibonacci sequence, right? The state is dp of I, which we can consider it is the length of the longest Fibonacci sequence ending at I. And the base case is going to be dp of 0, which is length of longest Fibonacci sequence ending at 0, which is 0, right? Same thing for dp of 1, which is length of longest distance Fibonacci sequence ending at 1, which is, well, that's just 0 as well. Ending at 2, that's where it changes, right? So ending at 2 means, well, equal to 1 if a 2 is equal to a 0. So actually, if you have, let's say, 1, 2, 3, 4, right? Or maybe let's do this 3, 1, 3, 5, or maybe 2, 3, 5, right? So this will be 0, 1, 2, 3, the indices, right? So ending at 2 is here, right? This is ending at 2. So it needs to be a1 plus a0. Else, so at that point it would be 3, right? Else is 0. So okay, so now that we have the base case, we can try with dp of I, which is going to be always dp of I minus 1, right? The previous one, either we don't change it, right? Or dp of I minus 1 plus 1 only if ai is equal to, we need to determine the previous and the one before that, the sequence, these two elements. So the problem here is deciding this, where to keep the sequence, right? So that's the main problem here, is where to keep the sequence. We can, instead of keeping the length, just keep the longest, right, itself. So longest fib and the sequence is at 0, so that would be empty list. We could, for example, decide that we are just going to, for these ones, we are just going to keep that, and then for this one, we could maybe decide to do this, right? And then if we do that, then, well, it becomes easier, right? So we can't do max though, only if we are going to do max with keys equal to length. And then here it's plus 1 if ai is equal to dp of I minus 1, right? Minus 1, and then plus dp of I minus 1 minus 2, right? And then at the end we can return dp of n, the length, and -1, of course, right? So let's try this. So the initial one would be dp of, so first thing is we need to have the length of the array. Now if n is less than 3, we need to return 0, at least 3, right? Then we need dp of 0 to be equal to a of 0, and then dp of 1 to be equal to dp of 0 of 1, and here dp is actually 0, 4. We need like a list here, right? That's the value, and the rows are n, right? And so dp of 2 is going to be equal to, well, we could start here doing for I in range of 2 to n. Well, we could just use this definition here, and then at the end maybe return dp of n minus 1. So I need to call this next, or choice 2. So this is kind of our choice 2, and this is choice 1, right? So otherwise it should be 0 here. Here it should not be +1, it should be plus a of I. And here it should not be the sequence, it should be the line. Okay, one of them seems to have yeah, I'm putting 0 here, it shouldn't be 0. If it's not working, yep, I should just put empty. Okay, seems like these two last ones are correct. And then the two middle ones are not, the first one is. So the two middle ones are not correct. And 3 are correct. The two middle ones are not. Okay, So there is a small error there. So here, if this is not working, then we will just fall back on choice 1, right? Okay, yep. So let's say the second use case, this one fails. Let's see why. So 1, 3 should not be counted, right? That's the problem here. So let's say this is res. Now so it's only res if res is at least 3, right? So bigger than 2, else just 0. What if we add 12 to that? Okay, so we didn't even try 7, 11, and 12. One and 11 and 12 should work, but we never tried them. Because here we just try I minus 1. I think this is getting a little bit more complicated than it needs to be, so let me try to restructure it a little bit, right? So first let's just keep a res initially at that, and if we can just return that res if it's bigger than 2, right? Otherwise just return 0, right? And then here we can start with a range of n and try j to be after that, right? And then here we'll need to have AB and then length, which are, right, A is going to be AI, J is going to be AJ, and then we need the set here, which is going to be the set for A, so that we can check if A plus B is in there. And the length is going to be at least 2, right, for A and B. And then here we are going to check all the occurrences that give us A plus B. Then we are going to say AB is going to change to be B and A plus B. This is what Fibonacci sequence does. And then here we are going to have the length being equal to let's give it L plus 1, right? Because we just found a new one. And then here, res is going to be equal to max of res and L. So the maximum sequence contains these two. What else? Let's see. Okay, nice. That looks to be working and is a lot simpler. Submit. Cool. Yeah, cool. So that passes my